Phillip Perry has been with Jamesway a number of years, spent a number of years before his time at Jamesway managing hatcheries, has a lot of experience in the hatchery and hatchery management, and provides a lot of great information for us, not only on multi-stage, which we'll be talking about today, but all incubation systems. And his topic today is going to be troubleshooting primarily in a multi-stage hatchery and some of the things we can do in our hatcheries to get them working the way they should. So with that, I will ask Phillip to go ahead and take over the presentation here. And again, any questions along the way, go ahead and type them out as you get them, and we'll address those at the end of the webinar. So Phillip, go ahead.
Okay, I'm going to hit my share screen here, and hopefully everyone can see the screen, but sure have missed you guys. It's been a while since we've been out, but we have my telephone still, my number hasn't changed, and I still get a lot of calls from various hatcheries, and you're welcome to call us anytime. Any topics you may have, we'll try to help them. And then we also have our 24/7 text service, which I'm sure you're aware of by now, hope you are. But today we're going to be talking about optimizing the multi-stage environment. And one of the things that when we do go through this is primarily directed toward chickens, but it does work with turkeys or with ducks or other species. If you're using multi-stage, it's just a little bit longer period, as you know, for these other species. But today we'll primarily focus on chickens. I had given this presentation back in October 2018, but I've got some new added things to this that I hope you can glean from to improve the performance and optimize your multi-stage environment. So the first thing we need to take a look at is a basic understanding of your incubation equipment, whether it be Jamesway, whether it be multi-stage, single stage, anything that has to do, you need to have an understanding of your equipment to get it to optimize and to get it to operate properly. You need to know the needs and the requirements of the developing embryo. Each day there's a different need that the embryo has and requirement. We do have a chart that lists some of these requirements for chickens, and we're also developing a new one for turkeys and for ducks. So we're anxious to get those into your hands, just so that you will know what the needs and requirements. And it's also good, your staff that does the day-to-day routine in and out of machines, that they have a concept of what's going on as well, because you'll find that the more knowledge that they have, the better your machines will operate and the better performance. We need to know the input needs of the incubation equipment. So when we say the input needs, these are things that that the equipment requires to operate properly. So there's four basic requirements to these inputs. The first being electricity. You should have good, stable electricity. The components work off electricity. Your RTD probes, humidity probes work off of electrical values. And a lot of these values are to the 4th and 5th decimal point. So it's very important that you, if you find that calibration or the machine exhibits odd behavior, need to take a look at electricity. Make sure that it is stable. The second basic requirement for incubation is water. We talk about water. Our concern here is the spray or the humidity nozzles. So some of the things, that you have the correct pressure, that you have the correct spray pattern, that your nozzles are positioned properly. And we'll be taking a look at all these things with the spray nozzles to make sure that we're optimizing the water or the spray going to the cabinet. Compressed air, multi-stage machine has a 60 psi compressed air requirement, but we also, if you read in the manual, it's good, clean air. So we don't want any oil in the system. We just want it to be clean, and no water. If you clean the racks with water, you want to make sure the ends are closed on the tubing for your air to just keep it as clean as possible. And the last is ventilation, and this is something different I've added to my presentation. We're going to take just a little bit and talk about ventilation and its role to the machine. And you'll find that it's very critical. Ventilation, the wrong ventilation, I would say, creates a lot of band-aids I see when I go into hatcheries to get their machine to perform. If the ventilation isn't right, there's things that is done to the operation of the machine to make it work that is being caused by ventilation. So when I come and visit a hatchery, I think I visited, I think my last count is I visited anywhere from, I think I visited 45 multi-stage hatcheries last year. So I get out in the field a lot, and when you see me coming, you'll probably see a lot of these things that I try to give you as tools to work. But there's 4 basic checkpoints that I do when I check a hatchery to check to see where the performance is at. I'll usually select 8 machines. If you have 4 hallways, I'll try to get 2 from each hallway. And then from these checkpoints, we can determine the operation and whether you're optimizing your performance of your multi-stage. The first thing we'll look at is calibration. And we'll go review that, how to take calibration properly. We'll talk about incubator pressures and the concerns with pressures that provide the ideal laminar effect of the airflow through the eggs and the egg carts. The entrance crossbar temperatures. I know a lot of you all do that routinely, and that is a very good tool to see if your machine is being optimized with your setting times and whether its performance is where it needs to be. And then we also take a look at the exit end, the infertile egg temperature there. Again, these are all 4 of these checkpoints are tools that I use that I can get a numeric value, and then we can put those values on what they should read, and then we'll have what the tools the data that we need to try to correct some things that are out of balance. So this is the worksheet I use. This is going to be available at the end. We'll talk a little bit more about it, but here, when I go in, it records the pressures, the entrance in temperatures. To the right is a guide on when we take the entrance in on what the expected temperatures would be if you didn't do it at 24 hours after transfer. That's our timeline we try to use, but sometimes when I'm visiting, I'm not there for just after 24 hours after transfer. So I can use some of these other values and see if I need to be where I'm at. I know had a guy, hatchery manager, call me the other day, 48 hours after transfer, his crossbar was reading 101.5. So there is some other temperatures that we knew they were getting hot, and we were able to use that tool, those values, to use to determine how the machine operation is. In the bottom left is the internal egg temperature and how we fill that out in the calibration checkpoints. So the first thing we're going to talk about is temperature calibration, and it's very important that the placement of the electrotherm is next to the temperature and humidity probe. And the way we do it, we use a flexible non-conductive electrotherm probe that'll bend around the shaft of the temperature sensor of the machine. On the right, you see, let me get a pointer going here. So on here we see the two, there's you use a 3/8 inch plastic tubing, which is the same as your humidity line, supply line, and we use a 1/4 inch plastic tubing which is the same as your air line. And then we tape these together, and then we can slide it over the RTD probe and then put our temperature electrotherm sensor through there so that we get a precise reading when we calibrate for temperature. So looking at some of the results here, we see some incubators on the left, the set point of those incubators, what the display was reading, and then what the actual electrotherm reading was. And the offset, or not the offset, but the amount, the value was off when we took our readings. First thing we want to do is use a calibrated, up-to-date Cooper TM99. Doesn't necessarily have to be a Cooper TM99 electrotherm. It can be another instrument as long as you're satisfied that it is calibrated and it is reading properly. You want to ensure that the 3010 probe serial number matches your instrument. Every instrument and probe are married together, so that you always want to keep those two together so that you get the correct reading. A different electrotherm with a different probe from another electrotherm can have a different value when you take your reading. I remember one time I visited a hatchery and I asked to see their electrotherm. Well, they handed me a bucket of probes, I mean, literally bucket full of probes and one electrotherm. And so when we got to looking, we were able to determine that all of these were anywhere from 2 to 3 to 4 tenths variation just in probes. So this is a very important aspect of your temperature calibration. If your calibration is wrong or your calibrator is wrong, it can take you 21 days to recover, because you have to go through and have that first hatch. And if you're using turkeys or ducks, it's even longer than that until you realize, oh, that could be your problem, is you're out of calibration. The baffle covers the end of the probe. So in this illustration or this picture here, we have our temperature sensor here, but you can see the baffle is exposing the tip of that probe, which also, every time your spray comes on humidity, the probe will react very quickly and with the water cooling that it's getting and read a lower value. So this is why it's very important that this baffle needs put down. And I'll just add a little tidbit. If you've got some large temperature swings with your PT100 control or your 501, check to make sure that that baffle is not bent up over a period of time of calibration. Or some maintenance guys just bend it up, just get it out of my way so I can take my calibration temperature. But this does, I've seen machines alarm because of this being bent up too high. So this shows a picture of the baffle down over the probe, which is similar to the other picture we had. Excuse me, I'm gonna get a drink of water here. So this shows the baffle, how it's supposed to cover the tip of the probe during calibration and during operation of the machine. You want to make sure that that's covering. Want to allow your temperature to stabilize. I've been guilty of this. The nearer my electrotherm gets to the set point of where I think it should be, and I'll jerk it out and go to the next machine. So we want to make sure that we at least give it in a multi-stage machine at least 5 minutes, maybe put it up in place, droop it over your door outside the machine, and go do something, and then come back just to check it. But just allow your temperature to stabilize and not rush it too quick. And you want to take the reading while it's, as I mentioned, not calling for humidity. This can affect the value as you're taking it. The manual says every 3 months. I just want to have another clip here of a rooftop unit of a gold box with the PT100 controller. As you can see, this I think this is created from humidity, and it's just a sediment that over a period of time has collected this dust all over your controls. And this can affect not only the operation of the machine, but also short circuit that board and just get some bad behavior from the machine whenever you're like this. So I think every 3 months you should take an air hose, open that top box and spray that dust out of there so it doesn't affect the operation of your machine. Let me back up here. So when I, for this particular machine, machines that I was checking, it was a PS501. And so you can see a couple of them aren't too far off, but I'm sure Dr. Bramwell could comment on these, this 0.7, thinking that your machine is running 98.3. It's actually running 99.0. And we have an early hatch out of that machine, and we can't understand why. Well, right here is an example. I was at one hatchery that someone, usually when you get them certified and calibrated, the electrotherm sent back, it'll have an offset value of, I don't like to have my calibrator more than 0.1. And when you purchase one, you can ask for it to be the probe to be within 0.1 at 100 degrees. And so what had happened with this hatchery, it had an offset value on the probe of add 0.5 to the reading. And so you can actually see where they were off almost a half a degree because no one had, it was not noticed at the time. And then especially when you get new maintenance guys, we need to review that they have the proper tools, but that they are reading all of the components properly when they take their readings. Next, we're going to talk about the airflow and measuring the pressure differentials of the machine. So by doing this, this is the what we would call the airflow, typical airflow of our multi-stage unit. As you can see, the air comes in through the intake in your hallway where you on the entrance in where you set your eggs. This is the mixing chamber. The air is pushed up through the fans. The fans are pushing it over top of the racks, and then and this is where our temperature value is, whatever our set point being 98.3, 98.8 at this location. This air is then pulled back through the eggs in what we call a laminar effect. It's not a fast draw. It's not slow. It's just sort of just trickling back through the eggs evenly and taking the heat off of our oldest eggs here in our exit end and transferring that heat into the other embryos as long as they are in incubation to our first set. So these here might need an air value, air temperature value around surrounding the eggs of a 98.8. But by the time we get back here to our eggs that we just set, then we want to start them out at 100.4, 100.3, 24 hours after transfer to ensure that these eggs are getting heated up in time and will start the embryonic development. And as they push down through, then each stage of the egg is being pulled back through. But it's very, very important that this airflow, that we get the right air distribution through these eggs mixed properly as they come back through. Some of the tools needed for taking the incubator pressure. One is this manometer. Jamesway sells this. There will be, as Dr. Bramwell mentioned, a link at the end of the presentation. And also an email we'll be sending out where you can order this from Jamesway. But it's very important. It's the value is a point. You have 3 decimal points here because most of our readings are very, very small in incubation. Whether you're taking, you can also use this instrument to take pressure readings of the room and other values throughout your hatchery. You can also use the old Magna Healy gauge. A lot of times this is used for room monitoring just to make sure that the actual control, whether you're using a Titan control or a Jamesway room controller, I like to have these set up at the end of the room, independent of my normal room tubing, just so that I can monitor the room independently from what my controller's setting. a lot of times these magna-helix are connected to the tubing that controls the whole hatchery. So I've gone in and they'll say, well, my magna-helix says everything's correct, but it's actually, because it's with your regular room controller, your electronic controller for your pressure of the room, it's reading the same value that it is reading. So it's always a good measure to have an independent reading of the rooms to make sure that we have the proper pressure in those rooms. The values that we'll be looking at today are in inches water column. I know some of our European customers use pascals. So, but today the values will be in that, and we'll just have to convert them over. So the procedure to monitor this, what we call internal differential pressure, is the resistance created by the egg pack. We always enter, anytime we're doing anything in this cabinet, should always be entering through the exit in. It's less disruptive to the cabinet, to the things that are going on, the fan, the balance, air temperature, all that. When you open this entrance in, except for setting eggs, but when you open this entrance in, you're introducing all that outside air. You know that it's running at a high negative pressure with these fans running. As soon as you open that door, you imbalance that compartment tremendously. You're dumping in all that outside air, has to be mixed here, has to be filtered back through the eggs. So it is very important, again, that you always, any maintenance procedures, anything you're doing other than setting eggs, should always you should always enter through the exit in and through the owl doors. This will help you keep your weight down because it can be pretty tight fitting through those owl doors. But anyway, this is the best procedure to use. This is the procedure to use. So then when we're standing in our entrance in with our manometer, we're going to stick our tubing on the positive port, and we're going to slide it under the threshold of the first rack, and we're going to try to get it up under there about 2 to 3 feet. Some of our older manuals said to bring it back to the 5th or 6th rack, but we found it's not necessary. We get the same reading here, the resistance reading, as we do back here. So stick it on there, take your reading, and so when you take this value, if you're using a big J, 36 egg flat, the 6th rack should be turned when it reaches that position. For a super J, our reading should be between a 0.50 and a 0.55, and the 6th rack leveled in a super J. We do not recommend leveling the 5th rack. We may do another presentation on optimizing egg setting, and we'll discuss that a little bit more. If you're having to level the 5th rack to reduce heat in that cabinet, there's something else causing that problem. And then for the SST flat, we have a lot more resistance, and so taking our reading here, we'll take a reading between a 0.60, 0.62. If everything, all the seals, everything's working properly. With the SST flat, the 5th and 6th racks are level. So that's the procedure. So when you're taking these values, this is what you should see, and which would influence what you're reading if your racks aren't in the proper position. So here's some expected total pressure for a Super J. Inches water column is 0.50 to 0.55. So I went to a hatchery, wrote down my incubator numbers. I got 2 in each hallway. I wrote down how many buggies there were per side, because this can cause the reading to be a little bit lower than the value that you're taking when we're looking for a 0.5 to 0.50. If we have 5 buggies in there, then it'll be a little bit less. We take a right and a left when we take the reading up under. We'll do one side and do the other side. Make sure we get both 2 readings. So in looking at this group of machines, 3 incubators have a side-to-side difference in the readings. So and we'll look and see some of the causes of this. So we have 0.52, a 0.48, 33. We had a difference in side-to-side readings, and then a lot of these machines have very low readings than what was expected. 60 was all the way down to 37, and we'll take and see what some of the causes and effects of these are. So when we have a pressure imbalance, the things that we would look for maintenance-wise, egg racks can cause this a lower value. And when we're talking how the egg racks can cause this, one thing is that they're not turning their full 45 degrees. And a good way to check this is there should be 4 inches between the turning bars. When I'm stepping through a machine and going down that center aisle, I'll just take my fist a lot of times and just make sure that we have that 4 inches. Then I know that my eggs are turned the 45 degrees, which will create the correct resistance. If they're not turned the full 45 degrees, then there's less resistance and then the air just shoots over those eggs. Other rack issues can be out of square racks. The track has become worn and not level anymore, so it causes a gap in our rack. So as that air comes back over the top, when your racks are not tight at the top, it just goes right in between here and short circuits and doesn't go all the way to the end and back through our oldest eggs in incubation. Another rack issue I see be more of an operational, but a lot of times maintenance guys are called upon to go in after a set has been made to make sure everything was done properly, is that the racks aren't pushed all the way in. Especially if you have contract workers in your hatchery doing some of these things, then these are just things that need to be checked to make sure to get the proper to make sure that egg racks aren't a problem, that our values are low or we have side-to-side variation. Curtains are a big thing. We need to make sure that they are overlapped correctly. As we come down, the end one should be overlapping the next one so that we get the correct, I'm sorry, the end one should be inside of the next one coming down so that we get the correct, that way air will not be escaping out these or entering through these sides if they're not, curtains aren't put on properly, or if you have good curtain maintenance. I know they do become brittle and they break. We see them a lot of times. They're breaking, they're flapping on the end, and then also on the owl door, that we get this on the outside of the flap here to make sure that that air is being pulled back through those racks. Fan blades. Fan blades are very important when it comes to the total pressure. And one thing we want to discuss is, and if you've gone to get replacement blades, you're probably, why are there so many different fan blades and when I go to replace? So Jamesway has had many changes to the fan blades, and this is due to the manufacturer supply and the discontinuation of old products. So what we had to do was come up with other blades and combinations that work properly. And there's so many combinations that it's probably best for you to either contact our service department or me or Henry or Keith and find out exactly what blade and what spacing is proper for you to use. You've got 50, 60 hertz, takes a different blade, Big J, Super J, SST. You have the old motor mounts, you have the new motor mounts, and then we add spacing to all this. A lot of times I've gone into hatchery and the total pressure value of that machine was found to be due to the fans. And a lot of times we're finding that there are mixed blades within a cabinet, and that can really create some side-to-side variance, some poor hatching results when these aren't done spaced correctly and the correct fan is in there. And but I want you to be confident that Jamesway has done the research and to provide the correct blade and spacing for your application. Again, I think I mentioned this, but just contact the service department. And this is just some of the scenarios with the various blades that we've had to replace with other blades and their part number. And again, so it would probably be best for you to contact Jamesway with your application. Are you Big J, Super J, SST flat, and then whether you're using the old motor mount or the new motor mount. Once we have those things, we can direct you toward the correct blade to use. Because again, it does become confusing. The spacing, when you do space, if you're using the old blade and you go to the new blade, the PB5997, it has a 1/2 inch spacing. And when we say the spacing, it is at the highest point of the grill or the motor mount is where you're taking that measurement. It's not from the rings, but it's on the highest point of the motor mount toward the fan blade, taking at this spot right here. So you just loosen the nut, get that blade moving up and down real good on the shaft, and you can get a spacer and put up under here and get the correct measurement, be it 1/2 inch or whatever, a wood block, or I've seen metal used, metal blocks. Just slide it right here under this, let your blade go down against it and tighten it down. You do need to use plenty of force on that. We recently had a hatchery that they had set all their blades, but we went back in a few months later, all the blades were off. They had moved on the shaft. So it's probably a good idea. I think our manual says to check that every 6 months, that hasn't floated on you or moved around. But let's make sure that is in the correct spacing, correct blade being used with the correct motor mount. The next thing we'll look at is gaskets. Anytime air is allowed to escape around these gaskets, be it our entrance in, door gaskets, all of this affects that total pressure of the machine, and it allows the air to escape and not come back through our egg racks. You can see when this gap is, here's a rack illustration or picture here that shows where a gasket was completely missing when I went in to do a service call on this hatchery. So where do you think this air is going to flow? Is it going to flow through our eggs here, or is it just going to come right through here where there's no resistance? So got to get these gaskets worked out, and then I know that requires a lot of maintenance on these machines and upkeep. About the time you get all your gaskets replaced, it's time to another one becomes torn or has another failure to it. So just need to keep up on these to make sure we get the proper flow. Again, we mentioned the doors that they're latching properly. A good way, I'm sure you know, is to step inside, turn the lights off, and see if you can see any light around the door and around the gaskets, which would show that would be air leakage, either going out through the exit in or through your entrance in. It'll draw air in through there. Owl doors, talk about, I mentioned those earlier. These often get bent, and if I'm demonstrating the pressure within this cabinet from the entrance to the egg side, a lot of times I'll just stick my meter under the door and push that door open, and you can actually see the value on your manometer go down. It just shows you, again, it's a numeric value, a tool, a data that we can collect and find where air leakage is occurring. And this is a big thing here. Over time, they become bent. A lot of times they can be bent back in place to make sure that you get a good seal. I have seen some foam gasket material put in here if they were beyond repair, but that was, a good solution. to keep that air moving back through the eggs properly. Ventilation, I want to take a little bit and talk about the ventilation aspects of the machine, our intake and exhaust. It's very important to the operation of these pressure in cabinets that we're running the correct pressure outside the machine. This is where a lot of Band-Aids come in. It's where a lot of problems arise that we have to operate this machine not the way it's supposed to operate, and therefore creates a lot of microclimates within the machine. But ventilation is the fuel for our machines. It maintains the machine temperature, humidity, and airflow, or the pressure. The environmental requirements, 78 to 82 for our rooms, and 80 degrees optimum. Relative humidity is 50 to 60, 55% is optimum. A lot of hatcheries like to run a little bit higher. They feel like they get a better performance with 60%. So if you're in a colder climate in the wintertime, and that outside air gets very dry that you're bringing in, we really need to acclimate that air in the hallway before it enters the cabinet, because it does affect the behavior of the machine and the humidity, how often the spray comes on. Our room pressure, anywhere from 0.05, again, water gauge, to a positive 0.15. This will affect your pressure readings of your cabinet if you're running negative in that room, if you're overpressurizing your room on that air intake. It causes your dampers to not be in there where they need to be as the machine's operating. But again, just want to mention that the room pressure affects the internal pressures of that cabinet. If you're using a plenum for your hatchers, and some of the units use, some of our incubator customers also use a plenum for their incubator exhaust. If you're referencing that plenum pressure to the outside, it'd be a negative 0.05 to a negative 0.15. It's just about, there's no resistance at all across that cabinet. And then if we're referencing to the room, we would want to run a negative 0.15 to a negative 0.25 reference to the room, which is what most hatcheries do. They just measure it that way, and then they're not concerned with the outside air pressure, wind blowing, things like that for the plenum. Fresh air requirements for the incubator and hatch rooms are not consistent, but they're dependent on variable factors, and such as the damper opening of each machine. So you got a bank of machine, you might have machines that have a higher fertility, the dampers are a little bit more open. You have machines that are just set that are slightly closed. So the damper openings of the machine are constantly opening and closing, especially if you got electromechanical controls. It never stops, the damper. So this is changes our fresh air requirement of the machine, so that it makes it difficult to just have a manual setting on your ventilation unit for that room. So it's very, very good to have an automatic room controller that is controlling the pressures of that room. The amount of leakage in the room from doors, ceilings, and plenums. So we're constantly, hatchery managers, going in and making sure hallway doors are closed. They get left open, or they don't seal properly, or they're propped open. You can also have leakage in the ceiling and in the plenum. Adjacent rooms, a lot of times I see a washroom, you might have an exhaust fan in that room, and but you don't have any makeup air for that exhaust fan. And I've seen like when you start pulling hatch, they turn that fan on, and then our incubator rooms go negative, because the air is being robbed and pulled into another room. So we need to make sure that we don't have any leakage, or minimize the amount of leakage. The room humidity levels, again, affects the operation of the machine. if you're in the cool climate, let's make sure we get some humidifiers to keep a constant level of 55 to 60% relative humidity in those rooms. The amount of activity in the room, how often doors are open. A lot of, I've seen hatcheries that maybe after transfer, they clean the racks in the washroom, they'll push racks back into their hallway, their entrance and hallway just for storage, but they leave the door propped open. And so that room is having to acclimate the hallway next door as well as our machines, and just affects. So again, you know, one of the last things I did before I went home was just walk through the hatchery and close doors, which I'm sure a lot of you do. When we're going to look now at the controlling influence of our machine, and we always want it to be our entrance in, and we want it to be 60% of the value. And I'll show you how we do that. Again, we step through the machine, through the exit in, walk down the aisle, and standing in the entry in the entrance in, we attach a tube to our negative port, and we measure out into the hallway underneath the threshold. And what we would want would be somewhere around if we have a total cabinet pressure of 0.5, our reading should be about a 0.30 inches water gauge. And then doing the same thing, we're going to stand in our exit in, put the tube out. A lot of times, and I know I have done a lot of training where we stepped out and where we measured from the exit in, but really that value is probably not necessary, because a lot of times you're measuring into a hatch room here that may have activity going on. And so I like, if I get my total pressure reading here and my entrance in pressure here, that's really the only two values I need, because the exit in value will add up to our entrance in value. So we're going to take a look at how we calculate the pressure. First, here, Incubator 4 had 6 buggies. We had a left and a right average of 0.50. When we took our entrance in negative value out into the hallway, we measured 0.30, which when we divide it into 50 equals 60% of the value that from the negative influence of the entrance in. If we just take 30 and subtract it from 50, that gives us 20. Again, you can measure out into the exit in, but I just find it being so influential from that side, because you are hatching. I just do these two values here. And so looking at number 8, we had a 0.33, a 0.27, give us a 65-35, which is telling us the airflow is probably not too bad in this machine. 33, even though it was low, ended up at 59.41. Here, 38, it's what we call flipped. It's almost a balance cabinet between our entrance in and our exit in. Again, we got 62.38 here on 46. So how we calculate our entrance percentage is this value here. It's the entrance reading divided by the total average right and left, and will give us our pressure reading. So, and then our exit in, we just subtract our value here from 52, or just subtract 100% from that, which gives us our total value of, so we can figure out whether or not we're running our 60-40 or if we're out of balance. I hope this isn't confusing. I tried to simplify it. So let's just, but I just seems like a lot of times I explain this, how to do this to managers, and it seems like it's a little bit difficult to grasp, but let's just try to break it down here step by step, and to help you understand. So with Incubator 4, looking at 4, we have a total right and left average of 0.50. So when we stuck our unit up underneath the buggies at our entrance in, this was our value. If we would have done 52.48 on this one, we would have taken an average, so we would have called this 50, would have been the average. So that's how we come up when we say the average. Next example is when we measured our entrance in, we measured a 0.30 out into the hallway from the entrance in. And so if we take the entrance and divide it into our total, 0.3 divided into 0.50 gives us our 60%. So then all we have to do is just take the 60 minus 100 equals 40%. And this gives us our incubator 4 has a total proper pressure percentage of a 60-40 ratio. So this tells us that this machine is balanced properly and we got the correct airflow through back through our cabinet, back through our egg racks. So when we have the higher entrance imbalance, just say we have a 70-30, do we have any high ones here? Well, this one we have, here we have an 81-19. So we have a pretty high entrance in value which is causing this value to be higher and the exit in at 30. So we got a 70-30. So what are some of the things that would cause this? For this lower value, the exit in damper is more open. So this damper could be more open than our intake damper, which causes this value to go down and throws this value higher. So this would be one way, be one of the things maintenance related that can cause the imbalance. And excessive air leakage at the exit indoors. Whenever you take these measurements, you need to make sure your doors are closed because this can throw this off as well. And a lot of times I go into hatcheries, these handles are broken and you almost have to have somebody from the outside close the door to make sure it's shut properly. But if there's a little air leakage here, can cause this to have a lower reading. We'll take a look with our entrance in, have a higher, our exit in actually has the higher value, but our entrance in has a lower, it's a 50, we took this reading and it's a 55-45. So I want to ask why is this reading off? And so some of the first things I would take is that my intake damper is more open than the exhaust. So with this damper being higher, then this creates a lower value here, and also excessive air leakage around the entrance in doors. So these can affect this value being lower. The the damper has so much influence to this machine operating properly and getting the proper pressures within the machine. The best time to check the damper, it should have a 1/2 inch opening shortly after sets. Once they close up, when you set your eggs, the dampers go fully closed. So if you have the older electrical mechanical, I'll just put this in here, then you don't have this energy strip, we call it. It's the same. It should be a 1/2 inch opening here on both ends, on entrance and exit in when it's fully closed. The cleanliness affects this pressure. So on our exit end, which is normally where we have more debris, dirt, if you fog machines, sometimes they can get real gummy here. This dirt buildup can create this machine to actually be more closed here and cause a lower value, or excuse me, a higher value here compared to our entrance in. Squareness, I've had to go in and loosen these brackets to make sure that the dampers fit correctly. Again, I mentioned you would check your instrument strip. Here's a picture of an exhaust duct here. This will affect your total pressure. It's amazing. A 1/16 of an inch, the influence that it has on these ducts and things that can cause your pressure to be off. Here's a picture of a space saver with the intake duct. Some of you that have the conventional machines, you don't have this, but just another illustration of why my pressure was being badly influenced was when they had set the eggs. And I don't know how long it had been like this. This duct had been knocked off. And so this is going to affect the pressure values and influence your pressure ratio when you check your machine. I want to move now to a tool that I know a lot of you use. It's entrance in temperatures. And so we want to take a look when to do this procedure. It should always be done 24 hours after transfer. And we always enter through the exit in. Do not look at this picture. It is being done incorrectly with the door open. But it does influence the value of this reading here when we step in to take the crossbar temperature. So we attach our probe to our crossbar. In behind toward the eggs is where it's positioned. And you record the temperatures left and right. Again, you want your you want these to be stable when you take the temperature. So there is certain temperatures. If we're running a 98.8 degree set point temperature in a Super J cabinet, 24 hours after transfer, we should be seeing right and left temperatures of around 100.3. And so this machine, number 11, as you can see, is right on where it needs to be. Some machines have some variation, a lower or a higher than expected. This machine was kind of flip-flop. And I do want to mention one thing. On this, when these temperatures were recorded at a hatchery, I went in behind their person that their quality control person was doing them, and I always noticed that on the right hand side it was always cooler. And I had went in a couple hours after this person had been in, and I couldn't figure out why when we checked, her values were pretty even on both sides, but my readings were less. And we come to find out she was going in through the entrance in door on the right door. She always went in on the right door, closed it, and it created a cooler temperature here just from the time she took her reading. So, and then a couple hours later, when I did my reading, that coolness from that door and this air being dumped on the right-hand side caused this machine to run cooler. So again, all of this data should be corrected from entering the exit in door. First thing, we'll just take a look at some of the variations caused by an egg pack. Can be the fertility, when we have a right and left difference in, you can have a higher fertility on one side, and so you should have a balanced mix within your machine. Egg size, again, older flocks can be on one side, younger on the other, and then partial setting. Partial setting needs to be balanced in the cabinet. You don't want to have one side being partial and disrupting the flow of the air as it comes back through. And then we'll take a look now of things that can cause this entrance in values to be off. One is air distribution. Another thing I want to point out is you got to think of this thing as being it's one incubator, yes, but it's actually two incubators. When you look at, you have a rack of eggs on this side and racks of eggs on this side, but you only have one controlling temperature sensor of this compartment. So that's why we are very strenuous on having you make sure all these things are done correctly, where it throws the values off. And so it can really disrupt one side. Maybe the other side is doing things fairly close, but you're having problems with the other side. You'll find something wrong with the affected side usually every time due to either fan blades, gaskets, or something affecting that side. Personnel entering through the entrance in, things like that can affect it. Again, air distribution can affect the crossbar temps. So some of our air distribution would be our fans, venturi, our center outdoor, intake duct, exhaust damper, all of these, any air leakage around our doors, humidification if our spray pattern is different on one side compared to the other, can cause our crossbar temperature to be less or more. And calibration is a big topic too. Can cause those values to be running very hot. The next place that we collect data in our multi-stage is in the exit in, and it's our internal infertile egg temperature. And we use our electrotherm. So we candle and locate a top, middle, and bottom infertile. I like to get it as close to the rack as I can. I like to get an outside egg and as near the top as I can. Some of you guys run such a high fertility, sometimes it's difficult to find eggs and you just have to keep going up. But try to get these 3 eggs are the ones, top, middle, and bottom are the ones that we're looking for. We mark them with a marker, and then we punch a small hole in the egg. We don't want to break the egg. I like to just take a small Phillips screwdriver and just grind a small hole in it, open it up large enough to, insert my probe, and we allow the temperature stabilize. It's usually pretty quick going into a liquid. It'll stabilize fairly quickly, but it can be done. And then we record the position and the temperatures. And once we collect this data, we'll put it on our chart that I showed you, and we'll look at these values to try to determine what's influencing if the temperatures are wrong. So a top, middle, top and bottom, if at a 98.8 set point, should be near the set point, and the middle is usually a couple tenths warmer. The best time to record this is 2 to 4 hours before removing the eggs for transfer. If you do it earlier, you could have some cooler readings, but the best time would be to do it right before transfer. So here, we'll just look at incubator 2. We had a set point of 98.8. We had on the right-hand side, 98.8, 98.9, 98.8, and then on the left side, this machine was running very balanced from right to left. When we went in and looked at 11, we had a warmer temperature at the bottom, and we'll take a look at what some of the mechanical issues, maintenance concerns we have. We have one, machine 13 is running warmer than the set point, and 15 has a right and left variation, and in 17 we have some variation, but a cooler temperature in the bottom. So these are the things that we look for in regard to when we have a temperature. First step would be higher at the bottom compared to the top is typically an airflow. So then if we're hot at the bottom, when we take that top to middle and bottom temperature, then these are some of the things. A lot of times this can be fans, but any of these can cause that air to be going over top and just going directly to the bottom. It's typically an airflow. A temperature different than our set point, this can indicate calibration, which we saw some there that were warmer. So that'd be the first place to look if it's either quite considerably higher or considerably lower. And side-to-side variation can indicate airflow. If it's not one of the things that we were talking earlier about our eggs and some of the logistics of getting them set properly. And in temperature lower at the bottom compared to the top would be a spray concern. A lot of times when our spray nozzles come on, a spray comes over the top. If the droplets are oversized, it can fall right down and just seems like it makes this area cooler. So this will be the first place you would look to make sure that your spray nozzles are not clogged or in their correct position. Another thing I'll mention here, I have seen ventilation, wrong fan blades cause it to run cooler in the bottom as well. Here's a positioning of our spray nozzles. So our short nozzle is 8 inches and an eighth, and then it's 6 millimeters. And then our long nozzle is 8 inches. And then it's very important, the elbow is 8 1/4 inches. I've gone into hatcheries that have had this 8-inch measured from the ceiling properly, but they've had the elbow would be down here, so the nozzle's pointing straight up at the top of the cabinet. Seen it at the top too, where it has moved on here. So when you take this measurement, always make sure that this measurement is correct when you take these other two. The pressure at the spray nozzle must be a minimum of 65 psi at all times. I've been asked, what are some of how high can it be? I've seen it up to 100 psi. I don't really think it makes a whole lot of difference. The main concern is that we're getting the droplets atomized by 65 psi. Another thing is no sediment in your water supply, and we suggest a 10 micron filter to make sure that we're not getting sediment in and causing nozzles to get clogged. If you have clogged nozzles, then you're running, your temperature will usually be too hot, and you'll find overheating throughout the cabinet. So I'm just going to take a review here. Seems like we're kind of winding down. So just for a multi-stage optimum environment review of all the things we talked about, the one thing is the room climate. We would want 80 degrees optimum temperature with a 60% relative humidity. We would want a room pressure anywhere from running a positive pressure. Our machines don't like to have air forced down them, and they don't like to have air pulled through them. They just want the air available as needed. And the same for the exhaust. So we're just going to say we're running a 98.8 set point with a 85% wet bulb. Your wet bulb setting will be determined by your moisture loss of your eggs at 18-day transfer, which for multi-stage is looking for an average of 12%. Some companies are running 84, seen some at 86. So that point is reference to your weight losses, how you want to run it. So with a 98.8 set point, the top position should be 98.8, 98.9, and 98.8. So these will be the correct values when we took our temperature reading. Flowing through the eggs at our crawl spar temperature at our exit in, we're looking for 100.3 degrees here. And then with our measuring our pressure differential from the entrance into our egg side, for a Super J, we're going to say 0.50 inches water column. And then we would measure from there out into the hall. We should get a 0.30. And so to give us our correct optimum environment, which would give us a 0.20 on our opposite side for the correct reading. So that kind of brings us to the end. And I guess, Keith, Dr. Bramwell's been collecting questions, and we'll try to answer them. We just wanted to let you know that you can, for some of the documents we have and some of the tools that I showed you, and we also have some recommended spare parts for multi-stage. You can access all these by sending us an email at webinars@jamesway.com, and we'll get you the information you may need to get your multi-stage up and running as needed. So I guess with that, I'll let our moderator, Dr. Bramwell, take over, and I'll get a drink of water.
Okay. Thank you, Phillip. Excellent job, as always. A lot of great information on our multi-stage incubation. We have a little bit of time for some questions here. Not a lot, but if people do have any other questions, they can send them after the fact, and we'll get them answered. One of these is opening the incubator doors from time to time, and we know has an effect. How much of an effect? You mentioned that in your presentation. There's an effect. You know, how much of an effect would you predict with people just opening the doors and check?
If they're talking about the entrance in, I would say it'll affect that machine for a couple of hours. It does. It takes a long time from what we've done as far as temperature, and also and just a quick example. We changed some fans out in a machine that was had the wrong fan blades in. It took that machine overnight to correct the pressure value. We tried to take the value about 3 hours later after we had changed the fans, but it was really the next day, 24 hours before it balanced out. So it is having an effect when we enter that entrance in. It should always be the exit in.
And
now, yeah.
Because you mentioned that, how it'll cool that down. Yeah, what it does is basically it's going to delay your incubation because now you're a little bit cooler. So every time you get in there, so we always recommend, don't get into them unless you have to. If you have to get in there and do some work or some checking, that's fine. But the fewest times you can get in that machine, open the doors and in and out, the better, because that cabinet's trying to maintain an environment. And every time we open the door, we're making it have to readjust that environment. So it will have an effect, particularly it'll let some heat out and may give you some warm spots, but also cool spots.
Sure.
Thank you. Yeah. Okay, so another one kind of related to this is the ununiform temperatures inside the cabinet. You mentioned that in your presentation from top, middle, bottom, side to side. Can you just kind of briefly summarize what we do when they're getting those measurements, seeing ununiform temperature readings?
Well, the first thing we need to do is find out what maintenance concerns could be causing that. So whenever you see values that aren't right, as I took you through each step, you see there are many working components of this machine that affect the overall temperature throughout the cabinet. And then you add that factor into the eggs you're setting, your egg pack, fertility, various setting patterns, things like that can cause it. So yeah, there's many things that cause it, and the best thing is just to review some of the where you have recorded some variations. Look back through the presentation and try to see if you can pinpoint where to look at to get your temperatures balanced.
Yeah. Okay. What effect will like a mix? And I've heard this. I've seen this myself. You've been in. I'm sure you've seen it. If you've got a mix of blades or spacing that you talk about the proper blade. So what if they have one type of blade on parts of the machine and another type on another part? I mean, how much of an effect is that going to have?
It's if you're having a extremely long hatch window and not good results, it could also affect chick quality because the machine is just it really runs at an imbalance whenever we don't have all 6 blades or 4 blades if you're turkeys or whatever. If you have different blades, different spacings and motor mounts, that's some of the things you would see.
Okay. Another one, and it was asked, when you talk about right to left of your machines, are you like, is that entrance in right and left side?
Yes.
Right left side. How do you describe it?
Yeah, I apologize. That was on my mind as I was going through the presentation, and I kind of slipped. But yes, so the right side of the machine is always viewed as the entrance in. So every value, everything, when you get on the exit in, even though you're on the exit facing left, that right side, that will be your right side of your machine.
So yeah, we need to make sure that people do that when you're taking those measurements. It's like when you're walking up there and doing right side, when you go and take your other side, we're still have right and left. Okay.
That's correct. Yeah.
Thank you. I'm trying to look at one comment I'm going to make. I've had several different comments on here again about that, not necessarily questions, but in the question queue, comments on that is how can we get this video, a copy of it, because there's so much good information in there. I've answered some of them in text as we were going along, but this will be made available. You'll get a link. at the end, within 24 hours or so, you'll get an email with a link to this presentation, the video. So all this good information you can get after the fact, review it, look at it at a little bit slower pace if you want. Philip has on here the webinars at jamesway.com. You can send questions there. Also, if you don't have Philip's personal or email or phone number, you can request that. So if you want to communicate with him directly, you can do that as well. With that, I think we'll wrap up. Thank you all for participating and joining us. I was looking at some of the attendees here, and a lot of people I recognize and know, and appreciate you joining in, and hope that if you have any questions down the road, you will let us know, and we'll be glad to help you in any way we can.
Yep.
So thank you much.
Thank you. Thank you all for your time.